Hi, so in this video I'm going to go through part 3 of question 1 on the 2012 math paper. So in this question they've given us two equations, 2x plus ky is equal to 4 and x plus y is equal to k. And they want to know when we're going to get positive real solutions, x and y. So I guess we might as well just try to solve these two equations then, if we are looking at for solutions. So let's label this as 1 and 2. So if I take 2 and I rearrange to get x, then we have this x is equal to k minus y. And then if I substitute this into equation 1, then this is what I get. And if I just rearrange this, so we've got ky and then minus 2y from here, and if I took the 2k from this over to the right hand side to give us this. And now we might want to divide by k minus 2 to tell us what y is, except we don't know that k minus 2 isn't 0 and we can't divide by 0. So we're going to have a look at this either when k minus 2 is 0 and when it isn't. So we have these two cases when k minus 2 is 0, so k is equal to 2, and when k minus 2 isn't 0. So first let's look at this. When k minus 2 is 0, then, okay, let's call this star first. So when k minus 2 is 0, then if we look at star, we see that, okay, so on the left-hand side, of course, this is just going to give us 0. So on this right-hand side, well, we know that k minus 2 is 0 implies that k is 2, right? So when we have 4 minus 2k, that is 4 minus 2 times 2. So essentially what we have is this, because k is equal to 2, we've substituted that in, and we see that we have 0 on the left hand side, and on this right hand side we have 4 minus 2 times 2 is still 4, so we have 0 is equal to 0, and so star is always satisfied, and so we can have any y and this will still work. And then because x is k minus y, we can have any x as well. So we actually have infinite solutions in this case. Okay, so what about when k minus 2 isn't 0? Well, then we can divide by k minus 2 here. So we're going to get that y is equal to 4 minus 2k divided by k minus 2. Now, remember, we are looking for positive real numbers, right? So for y to be positive, we need both the top and the bottom to be positive, or both the top and the bottom to be negative. So we need 4 minus 2k to be greater than 0 and k minus 2 to be greater than 0, or both of them to be less than 0. And we see that, so if I've called this first condition A and the second line B, so if we rearrange these to get k on one side, so this first one gives us that 2 is greater than k. This second inequality gives us that k is greater than 2. So k has to be both less than and greater than 2 at the same time, which is not possible. And similarly for the second one, for this first inequality we need k greater than 2, and for this second one we need k less than 2. So again, this doesn't work. So we can see that when k minus 2 is not equal to 0, then we are actually going to get no solutions. And so we see that we only have solutions when k is equal to 2, and that is the same as C.